Hello everyone, and thank you for joining the 46th Mydbops My webinar. Today we are focusing on a very important topic, AWS Database Migration Service. We will cover the architecture, best practices our team uses, and the real-world limitations you need to know. And here to walk us through, it's our expert Arun. Arun is a database engineer here and has lots of hands-on experience with DMS projects. Just a quick note, if you have any queries, please put them in the comment box. We will answer them immediately. Arun, over to you.
Thank you for the introduction, Shiny. Hi everyone, my name is Arun and I am a database engineer. Today I will be walking you through the AWS DMS, its architecture, best practice and the key limitations. So here is our agenda for today. So we will start with an overview of AWS DMS. Then we will look at its architecture and its core components. After that, we will discuss on the migration strategies and real-world use cases. We will also cover the common challenges, best practice, and performance tuning. Finally, we will look into the security consideration and limitation. Now, let us know what the overview of AWS Data Migration Service. So AWS DMS is a completely managed by the AWS, and it is a service that helps us to migrate the databases from source to target database with minimal downtime. It supports both homogeneous and heterogeneous migration, and also and it makes more flexible and for simple and complex migration. It supports structured and unstructured data migration by moving it from source to target according to the selected migration mode. Essentially, DMS will simplify the migration process and reduce the downtime during the switchover and ensure the data integrity. Now that we understand what DMS does, let's look at its architecture and core components. As this diagram shows how the DMS transfer the data from source endpoint to source server to the target server and the replication instance and as the entire migration process. While the CloudWatch, it keeps tracking the replication instance and the migration and also overall the performance. Now let's go through the each core components of the DMS. The replication instance, this is basically a compute resource which is managed by the AWS. It establishes the connection between source and target database. So always the replication reads the logs from the source endpoint and convert the data into CSV and then write into the target database through the target endpoint. So here both source and target endpoint, so it denotes the source database and the target database. The data migration task, this task defines what kind of data has to be migrated and how to migrate it. We have three kinds of modes for the DMS, like full load CDC and full load plus CDC. We will discuss it coming slides. And the CloudWatch is a service which is used to monitor the overall replication task and overall performance during the migration. And it is especially the CloudWatch is very useful during the troubleshooting purpose, and it is always keep log the DMS task logs. Now let's look at what are the migration modes available in the DMS. So on the AWS DMS, we have three major migration modes. First, the full load. This method, it copies all the historical data from the source database to the target database. And once the full load is completed, automatically the DMS will get stopped. The second one, change data capture. We also call it as a CDC. So it captures only the new changes from the source database and applies to the target. The third one is full load plus CDC. This is the most common approach. Most of the DBS are used for the migration. First, it will perform the full load, like copy all the historical data from the source database. And once the full load is completed, it automatically switch to the CDC to keep capturing the ongoing changes. This way, both source and target database all are in sync. So choosing the right migration mode, it depends on your business requirements. Okay, now let's look at it. So some real world scenarios where the DMS will use. So the homogeneous migration, when we are using both source and target your databases or same engine. For example, migrating from EC to MySQL to RDS MySQL. So in this case, both schema, data types, and even database features all are similar. So the migration is faster and the simpler. When going with a heterogeneous migration, so here both source and target are different database engine. For example, Oracle to RDS MySQL. So in this case, the schema, the data types, and even the database features, and also the SQL pattern also will differ. So here we need to do the schema conversion. So here the steps got increased. So we need to use AWS schema conversion tool. So using this tool, we can convert the data type from source to the target database engine. Once that is completed, then we can go ahead for the migration. Most of the organization uses AWS DMS to migrate their on-premise database to cloud database because the DMS gives a continuous replication and using that, and also we can do the cutover with minimal downtime. DMS allows structure chain migration, such as migrating a data from non-partition table to partition table on the target server. So using a transformation rules, we can do the schema rename on the target server. And also we can only migrate the required tables data from source to the target server. DMS can also be used for the continuous replication, which is very useful during the disaster recovery. The DMS will support the analytics pipeline. So moving a data from source database to data warehouse, will be easily, and it avoids the analytics team to use the production database. So in case of any issue, DMS supports the reverse replication for the rollback mechanism. Some common challenges we'll face during the DMS migrations. So, full load migration can take a long time when the database sizes are in TBs. So, we need to wait until the full load complete because during the full load phase, the source and target database will not completely sync. So, we will get unupdated data. And also, especially in the heterogeneous migration, we have a data type limitation because some source data type is not um, supported on the target database. So, which can lead to the data type conversion issue. And when migrating a large LOB columns to the target server, it make it slower because of the size of the data. So this need some special handling, and we need proper LOB sizes. If we have a latency between source and the target, then it can leads to the slow down the data transfer between source and target. So the migration will take more time. And also the another important to keep consistent connectivity between source and the target server until the switchover gets complete. In case if any interruption between source and target, it can cause the failure. Let's start with the best practices. Before starting the migration, it is important to pre-validate the source and target configuration to ensure everything is compatible. So once and the network connection between source and target should be fast and reliable for low latency migration and fast full load. If possible, use dedicated replication source server for your DMS purpose. using a production, it casts load on the production DBs. Always do the pre-assessment test to identify the potential issue before running the actual migration. Once the migration is running, monitor the replication task regularly and find the any issue, spot issue or performance degradation, and consider enabling a CloudWatch alarm for real-time alerts. And try to avoid a schema changes during the migration, as this can break the replication task. Keep your migration tasks simple and avoid a complex transformation rules to reduce the errors. Finally, ensure that the bin log retention is at least 24 hours, giving a CDC to enough history to capture all the changes without missing any data. Performance is another critical during the large migration. So let's discuss performance tuning. When migrating a large table, you can enable the parallel load by increasing the max full load subtask value to 8. So this allows DMS to create a multiple target data set. So the multiple tables are loaded simultaneously. So which speed ups the uh, full load migration. And also you can adjust the commit rates and enable the batch optimized on your DMS task. So then we can reduce the workload on the target database. So this will help us the full load and run much faster without overloading the server. Using a table partitioning method. So using this table partitioning method, like by splitting the larger table into a smaller chunk, like range-wise IDs. So making this migration more manageable. For example, we have a 1 TB of single table. So earlier it is taking a 5 to 6 hours uh, to complete the full load. So using a table partitioning for a particular table by splitting it by making a chunk, so it can complete within 1 or 2 hours. For for that for any table which contain a large LOB column, you can use limited LOB because it is a faster and the data transfer will be more effectively. If the LOB data is not needed in the target server, it can be disabled on the DMS task and it will save the time. So finally, always keep your replication instance as the same reason of your target instance. So this reduce the network latency and also improve the overall migration speed, ensuring smoother and faster migration. Let's look at some MySQL parameters we can tune on the target database during the migration. So it's not required any restart. We can set InnoDB flush log transaction commit and sync bin log to 0 during a full load. So this reduce the disk IO and make bulk insert much faster, but they are low durability. Once the migration is done, switch them back to the one for the safety by increasing the InnoDB change buffer max size to 40 to 50%. It gives more memory for handling the index operation. So it also speed up the bulk insert during the migration. Setting a InnoDB change buffer to inserts to make sense because full load is mostly a insert. So this way MySQL buffers them effectively, reducing the random IO. And also when we set InnoDB flush neighbor to 0, the MySQL will won't flush the unnecessary neighbor pages. On SSD, this avoids the wasted IO and improves the migration performance. By raising the by increasing the InnoDB capacity and InnoDB capacity max, so the MySQL will handle more IO operations per second. So this helps to background flushing and inserts them smoothly without without latency. Also, Increasing a higher value on InnoDB LRU scan depth makes MySQL to free space faster and avoiding the slowdowns during the heavy insert. These MySQL variables need a server reboot, so we must plan carefully. So setting a log bin is off. Means disabling the binary logging. This reduce the overhead and speed ups the full load. Turning off the InnoDB double write and InnoDB adaptive hash index to make it cut down the disk IO memory and the CPU usage. So which is improves the performance during the big migrations, and also increasing the InnoDB log file size to a higher value. Uh, so it helping the bulk insert and run faster. Disable the redo log during the full load phase to speed up the write on the target database. All these parameter, uh, all these parameter which help us to get faster migration by reducing the disk IO and optimizing the buffer usage. But remember, after the migration, always revert them back to the safer default value for the production stability. How to choose the right LOB size in the DMS during the migration. When migrating a tables which contains a large LOB column, large data type such as text or blob, so we need to calculate their size for optimal migration. First, we need to start by identifying the tables with LOB columns. We can use the query one. This query lists all the tables and column names and its data types. Once we got that, next we can retrieve the maximum size of the each LOB column data type using a query tool. So this tells the target LOB value in each column. After getting all the value, sum all the maximum values uh, across all the tables, and then convert the total value from bytes to kilobytes, because the DMS will accept the values in KBs. So, and add 10% buffer for the safety migrations. Finally, we will use this calculated value in the DMS limited mode to ensure a large objects are migrated effectively without slow down the full load. Now let's talk about the security consideration to ensure the safe migration. Always grant the required privileges to your replication user. So this follows the principle of least privilege and limit the potential risk. So you can refer these grants from this snapshot. Ensure strong password for your DMS user. Use 16 digit with some special characters for all your DMS user to prevent unauthorized access. Use SSL or TLS connection to encrypt the data during the transfer. It keeping from the interception. And also apply the right IAM roles and policies for your DMS tasks to control the access securely. Lastly, restrict the public access to your replication instance or your databases, which minimize the exposure to the external threats. Follow this practice, so it will ensure that your migration is both efficient and secure. Finally, there are few limitations on the DMS. So AWS DMS does not migrate the triggers, views, and functions. So to move these objects, we have to use manual approach to the target database. During the ongoing replication, we need to avoid a schema changes, such as creating a new tables or modifying the columns. So because DMS won't support DADL and it leads to a replication failure. when migrating a very large table, one migration task is not sufficient. So we may either need to tune the performance, or we can split the migration task into multiple DMS tasks to get more better performance. For a MySQL, we have specific binary log configuration are required to support the smooth replication. First, the bin log format should be set to as row. So every row level changes is captured on the binary logs. Bin log checksum should be none to avoid the replication errors. And also the bin log row image has to be full. So all the columns data included in the logs file. So these settings ensure the replication process runs smoothly and no data is going to miss. So here is the some reference link, so you can check for more details. Okay, now we are coming to the end of this today's session. So to quickly summarize, the AWS DMS help us to migrate a data with minimal downtime, picking the right migration mode and tuning the target database properly, so it can make the process faster and smoother. Always follow the best practices and keep an eye on the replication process daily to avoid any issues. And thank you for all your time and attention. Wishing you a great weekend. Thank you.
Thank you so much, Arun, for that informative and detailed session on AWS DMS. To everyone who joined us today, a big thank you for being here. We truly hope the session gave you some valuable takeaways and helps you in your work with migration. For those of you who are new to us, we are Mydbops, a team that has been around since 2016. We have had the chance to support over 800 happy customers with database consulting and managed services. We work with a wide range of databases: MySQL, MariaDB, MongoDB, Postgres, TiDB, Cassandra. And we are all about making database management simpler, faster, and better for our clients. We also believe in giving back to the community, so these webinars are one of the ways we share our knowledge, experiences, and learn together. If you found this session useful, please subscribe to our YouTube channel for more sessions and tech content. Follow us on LinkedIn to stay updated with our latest blogs, services, and events. If you have any further questions or require additional information, feel free to visit our website at www.mydbops.com or email us at info@mydbops.com. We will also be sharing the webinar recording in the upcoming week, so stay tuned for that. Thanks again for being a part of Mydbops My Webinar Edition 46. Have a great weekend.